Hello guys, so what's the first problem we are going to solve in this new year? Is 603 division 2 problem E, right? It's quite a difficult problem. So as always, we are going to explain this problem by introduce the example here, right? So the input give us a number. This number is the length of the following string. So the following string has 11 characters in it. And what's the meaning of each of the characters? So the first character is left parenthesis. So we write down a left parenthesis at the first position. And at the same time, we need to check if current string is a valid string. So this string is not a valid string because it has no close parenthesis, right? So let's move on. We got a big R here. So we move. 1 second. Let me try to move this cursor away. Cool. It's gone. The second character is a big R. So we move the pointer to its right. Here. Right? Then we check the string again. It's still a left parenthesis. It's still not valid. So we output a -1 here, right? And we move on to the third character. It's a little a. So we write down a at this position, right? And we check the whole string again. It's left parenthesis and a still invalid. So we output -1. And we got another big R, so we move the pointer to its right and check the string again, still invalid, output -1. And we got a little b here, so little b is just a random character, so we write down it and check the whole string again, still invalid, output -1. And we got another R here, means we want to move the pointer to its right here, right? And we check the whole string again, still invalid, so output -1. And here we got a right parenthesis, so we write down the right parenthesis and check the whole string. Cool. Right now we got a valid string, right? It has open parenthesis, has a close parenthesis. It's valid. Great. So the dips of the maximal dips of this parenthesis is 1, right? So we output 1. If we got a string like this, its max dips of the parenthesis is 2. In that case, we output 2. Alright? So let's move on. We output 1 here, and then we got a big L. Oh, sorry, we already got that one. So we move on to the next character, is a big L. So we move the pointer to its left here, right? And check the whole string. Cool, still valid. So we output 1 here, and move on. We got another right parenthesis. So we change this character to right parenthesis. And we check the whole string again. Now the string has 2 close parentheses. It's invalid. so we output -1. Then we got another big L, so we move the pointer to its left and check the string again, still invalid, so output -1. And the last character is open parenthesis, so we write down open parenthesis here and check the whole string. Cool, it got a valid string and its maximal dips of the parenthesis is 2, so we output 2 here, right? What's the dips of the parenthesis? Let me give another example, right? So what's the dips of the parenthesis of this string? It's still 2, right? 1, 2, right? Then how about this one? What's this one's maximal dips? Is 1, 2, 3, 3, right? So that's explanation of this problem. So we need to check if the current string is valid or not. If it is valid, we need to output the maximal dips of the parenthesis, right? So how do we solve this problem? Okay, spoiler alert, the trick to solve this problem is called a segment tree. So let's move on. What is segment tree here? Actually, if you already know segment tree, you can be sure that you can understand what I'm going to say in the following chapter. But if you are not already know the segment tree, you can still watch the rest of this video, but if you cannot fully understand it, you can check out segment tree from other sources, right? So let's move on. Let's say we got a string like this, right? Its maximal dips is 2, right? And it is valid. We can transform this string to an array with the 1 and -1, like this array, right? So when we when we create this array with numbers, we transform left parenthesis to +1 and transform the close parenthesis to -1, right? So what we got here is this array, and as we can see, if this array's sum is 0, it means this array has the same number of open parentheses and close parentheses, right? It means that it might be a valid array. For example, for this array, it has 1, 1, 2. The sum of this array is 0, right? It means it has the same number of open and close parentheses. And then for each suffix sum, it must be greater or equal to 0, right? If at some point is less than 0, it means that close parenthesis is the number of closed parentheses is bigger than the number of open parentheses. That means the string is invalid, right? For example, this string, it has -1, -1, and 1, right? The sum of this string is 0. It has the same number of open and closed parentheses, but the prefix sum of this one is less than 0. It means the number of closed parentheses bigger than the number of open parentheses. So of course this array is invalid, right? So in order to make sure this array is valid, we need to make sure that each suffix sum are equal or bigger than 0, right? And what's the maximal depth of the string, of the parentheses? It means that the maximal prefix sum
What's the difference between prefix and suffix?
Did I say suffix before? That's an error. I want to mean prefix. Suffix means the last few numbers of this array and add them together. But the prefix means the first several numbers in the array, right? So if we want to know the maximal depth of parentheses, we only need to know the maximal prefix sum of the string, right? For example, for this string, the maximal prefix sum is here, right? 2. So its maximal depth of this parenthesis is 2, right? The depth of this string is 2, and also this string is 2, right? So we need to calculate two numbers. One number is the maximal the other is minimal no I here. Whatever, my English spelling is really bad. So first we need to make sure that the minimum prefix sum of the array is bigger or equal to 0, right? Second, we need to make sure the sum equals to 0. because we need to make sure that the open parentheses and the closed parentheses are equal, right? And what we output is the dips of this parentheses. So the number we are going to output is the maximum prefix sum, right? So let's begin. How do we solve it using segment tree? First, we need to calculate the 3 numbers for each. Sorry about that. For each node, right? We have 8 nodes here. And for each node, we need to calculate sum, minimum prefix sum, and the max prefix sum. So for this guy, the sum from actually it's only one node, so all of the 3 numbers are the same, equal to the value of this node, right? 1, 1, 1. 1, 1, 1 for this node, minus 1, minus 1, minus 1 for this node. So they're all same. So let's just skip this level, right? So let's push it up. So how do we get the second level, right here? So for this subarray, the sum of this subarray is 2, right? And the minimum prefix sum of this array is 1. Just one character here. We have 2 prefix sum here, right? One is 1, right? The other one is 2, right? Add them together equals 2. So the minimal prefix sum is 1 and the maximal prefix sum is 2, right? So that makes sense. And what about these 2? The sum of these 2 is minus 2. And we got 2 prefix sum here. One is minus 1, one is minus 2. Right? So the minimal one is minus 2 and the maximum one is minus 1. So this one we finished. So in the same way we get the other 2 nodes, right? And we move up, we push up 1 level again. So we get this level, right? So what about the first 4 numbers, right? This node has the information of the first 4 numbers, right? So how do we calculate it? For the first 4 numbers, the sum is 0, right? So we got 0 here. Because 1 plus 1 minus 1 minus 1 equals 0. So we got 0 here. And we have 4 prefix sums. One is 1 here. The other is 2. The third one is 1. And the last one is 0. So the minimal is 0 here. The maximum is 2 here, right? And this in the same way we calculate this node as well, right? So how do we calculate this node? By only by the information from its 2 children, right? From this node and this node. This is the critical part, right? So for the first number is sum, right? It's easy, just plus these 2 numbers together. So 2 plus minus 2 equals 0, so we get a 0 here. Because this node is the first two nodes sum, and this number is the second two numbers sum, so we just need to add them together, right? So this one is easy. Then how do we get the second one? The second one is the minimum prefix sum of these four numbers. So we have two options. First option is the minimum prefix sum of these two numbers, right? And the second option is that the minimal prefix sum of these two numbers plus the sum of these two numbers. So when we compare these two options, the smaller option is what we are going to use here, right? In this case, the first option is 1, right? And the second option is minus 2 plus the sum of the left node, which is 2, so equals 0. So in this case, we choose 0 here. Yeah. So in the same way, how do we calculate this guy? This guy is the maximum prefix sum, right? It also has two options. The first option is that the maximum prefix sum of its left node, right? It's 2. The second option is the maximum prefix sum of right node, which is minus 2, plus the sum of the left node, which is 2. So the second option is 1. So we choose the bigger one, which is 2 here. Great. So in this way, we can deduct a node, the value of a node by using its two children, right? So in the same way, we can calculate this node, and also in the same way, we can calculate this node by getting the information from these two nodes, right? So when we want to change a character in the array, for example, we want to change this node into left parentheses, right? How do we do? We just need to change this information, right? This node, we change it to 1, 1, 1, right? Because now it's the open parenthesis, so it's a positive 1. So this node changes, then we need to push it up, change this node, right? So how to change it? As we did before, the sum of this node, we need to change it to minus 1 plus 1, which is 0 here, right? And the minimal prefix sum has two options. One is minus 1 here, right? One is 1 here plus the sum of the left node, which is minus 1, which is 0. So we choose a smaller one, which is minus 1 here, right? And for the maximum prefix sum is first option is minus 1, second option is 1 plus minus 1 here, which is 0. So we choose a bigger one, 0, right? And we push it up again, right? Then push it up So eventually we can get this node's value, right? And we need to check this node to see if minimum prefix sum bigger or equal to 0 and the sum equal to 0. So if these two values are satisfied, we output the third value, which is the maximum prefix sum, right? So I guess that's it. All we need to do is to create a segment tree like this one and update the characters at each step. And after finish each update, we need to check the root node here to see if the segment tree satisfies the conditions, and if the answer is yes, we output the maximum prefix sum as the answer, right? So that's it. We are going to read the code here, right? First, we clear all the joins, and this is the code, right? So we have a segment tree here, and it has three arrays. The first one, as we said before, is the sum, and the second one is minimum prefix sum. The third one is maximum prefix sum, right? This here is where we set the initial value, and then also this part, right? These are the initial values, and then we iterate through all of the characters. If we encounter big R, we just move the pointer to the right. If we encounter big L, we move the pointer to the left. So a little edge case here. So if we move to the leftmost position of the array, we can't move to its left anymore. So we stay at the position 0, right? So if we got the open parenthesis, we update it, right? Update that node to 1. And if we got a close parenthesis, we update that node to -1, right? If we got other parentheses, other characters, we update that node to 0, right? And after we update the segment tree, we need to check the root node, right? Check those three conditions we discussed before, and output the maximum prefix sum, or output -1, right? And this part is the push up part, and this part is the update part. So for the update, if the update means we are going to change a character, right? So we change all of its 3 values to that to the target value, right? And we push it up from one level to another, right? Like this one. And in each push up, we need to calculate those 3 values. So we also already discussed how to calculate those 3 values, right? So after calculated, we push it up again until we got got to the root node, right? Okay, I guess that's all for today. Thank you so much for watching. Happy New Year!